All right, we're going to do a little warm-up before we start the related rates section. So basically, your task here with this warm-up is to take the derivative with respect to t. Okay, take the derivative with respect to t. So let's start with something simple like number 6. So I'm going to take the derivative of the entire equation with respect to t. So I'm going to write it out by putting my command here at the beginning, at the left side and the right side of the equation. All right, so when I say take the derivative with respect to t, first thing you need to do is check to see if the variable that you're working with and the variable that is the command are matching. And if they are not, you're going to need to do implicit differentiation. So that means I'm going to take the derivative of v, which is 1. And then after that, I'm going to have to write my implicit notation, which says take the derivative of baby, but you don't know what baby is. So we would call that dv dt. So the dv on top means take the derivative of v, and on the bottom means with respect to t. Let's try that again. So over here on the right side, take the derivative with respect to t of x cubed. These variables do not match, so I'm going to do implicit differentiation. So I take the derivative of x cubed, which is 3x squared, and multiply by the derivative of baby, which means x is the variable, so dx, with respect to dt, because that's what the command tells us to do. And at this point, I would be done. There's nothing else that we can do. Let's try that again. Let's go over to number 7. So again, I want you to take the derivative with respect to t. So let me get this set up. And again, remember that if your variables do not match, you're going to have to do implicit differentiation. So let's see what we've got here. So for the first part, do my variables match? No, they do not. So I'm going to take the derivative, which would be 2x, but then multiply by dx dt. Okay, here in the next set, the variables do not match again. So take the derivative of y squared and you get 2y dy dt. And then one more time, derivative of z squared would be 2z dz dt. Okay, let's do one more. Let's go down here and find one, maybe 2 more. Ooh, how about 11? So let's do the derivative with respect to t. Show you another way you can write it. You can just put the whole equation in the bracket like this. You just go through one step at a time. So the derivative with respect to t of v. Well, the variables don't match, so I would take the derivative, which is 1, and then put dv dt. And then over here on the right side, r is your variable, which is not the same as the command. So we're going to take the derivative of all of this first and then do our implicit step. So r is my variable, so I'm going to do power rule. It means take the power to the front and multiply. So 3 times 4/3 pi, and then subtract 1 from your power and you get r squared. But then because my variable does not match my command, I do need to still have dr dt. One thing you could do is multiply 3 and 4/3 to simplify. So that would just give me 4 pi r squared dr dt. All right, now let's do one more and then we'll be done. This over here, number 13, this is interesting because I'm asking you to take the derivative with respect to t. And this equation does have t's in it. So let me show you how that looks. So take the derivative of x, x of t, I would just call that x prime of t. And then take the derivative with respect to t of negative 5t squared. So that I'm just going to write negative 10t, that's the derivative, and I do not need the extra implicit step here. I don't need to write dr dt or dv, any of that, because my variable does match my command. So you're just going to do a regular derivative when that happens. Here again, I have 30t. Take the derivative with respect to t, and you just get 30. So there would be your answer.